All right, there is one theorem in lesson 6.3 that we hadn't talked about yet. I, to be honest, forgot about it yesterday during first period and during fifth period as I'm going through things again with that class. I realized, oh gosh, there's one more thing I have to come back and cover today. But otherwise, we're not going to spend any time on 6.3 just because we don't have time, and it is very similar to what we've already covered in 6.2. So moving on today to talk about properties of special quadrilaterals. There's 6 theorems are true for special parallelograms. Sorry, I should have said parallelograms. Parallelograms are quadrilaterals, but they're more specific than that. The first one says each diagonal of a rhombus bisects 2 angles of a rhombus, the 2 angles of a rhombus. I'll pause while you copy that and then we'll talk about it. So what this is saying is if I draw in the diagonals to this special parallelogram, what is this?
Diamond.
Yeah, what's the math name for a diamond? A rhombus, right? So this is a rhombus. And so this is saying if we draw in the diagonals to this rhombus, it's going to bisect the angles. And so that means those angles are going to be equal. Okay? It also, all 4 of those are going to be equal. Anybody tell me why? Let's call this just A, B, C, D. We said A, B, C, D is a rhombus, but what's a more general name for it's also something else? A few questions yesterday where you had to identify, not yesterday, but the day before in 6.1, you had to identify what all shapes it could be, right? One shape is a rhombus here. That's the most specific name to this. But what's a more general name to this?
Parallelogram.
Parallelogram. And so yesterday we learned that what's true about parallelograms? Opposite sides are equal or congruent. And also, what else we learned?
Opposite angles.
Opposite angles are equal. So that means angle A, this big angle here, is equal to angle C over here. Well, if I cut this into 2 equal pieces, let's pretend that's 100 degrees and that's 100 degrees. What are each of these little ones going to be?
50.
50. Okay, so because it's a rhombus, this diagonal is going to cut that into equal pieces, so all 4 of them are going to be equal. This other diagonal here is also going to cut this one into equal pieces and this one into equal pieces. And again, now all 4 of these are equal because opposite angles are congruent. So angle D, that big angle D there, is congruent to big angle B. Okay? So all those things are true because it's a rhombus and those are the diagonals. Okay? Any questions on that? Okay, not hearing any. Let's move on to the next. Oh, let's go back. Make sure. Okay, good. I was afraid I skipped some. The diagonals of a rhombus are what? I did not draw a very good rhombus there. Diagonals of a rhombus are perpendicular. I'm just cleaning this up. So that means this angle right here is 90 degrees. So the diagonals of a rhombus bisect the angles, and the diagonals of a rhombus are perpendicular. Okay? Bless you. So a few things here that about rhombuses, I should say rhombi, that are true. Anybody still copying number 2 here? All right, I'll pause for a second. So here we have a rectangle, R-E-C-T, rect. The diagonals of a rectangle are congruent. That means this green line is equal in length to this red line. Okay, thank you. So those diagonals are congruent. That means then that RC, let me try that again. It's equal to ET. Reed says equal to extraterrestrial. It's a new meaning to ET phone home, right? Maybe you ever watched that movie? That's like eons old. Okay. They're equal. I'm about to, this summer, unless something falls apart, I'm going to build my 3rd house. Okay? This is a concept I use all the time when I'm building. If I want my slab of cement, if I want my bedroom, if I want my porch, whatever I want to be, to have 90-degree angles, okay? We say we want it to be square. We don't really mean literally a square, but we want the corners to be 90 degrees. I measure from diagonal, from corner to corner on the diagonal. And from here to here, I measure those distances. And if one is shorter than the other, then my slab of cement, my bedroom, my porch, my whatever I'm building is not square yet. It doesn't have 90-degree angles. Okay? If the red line was longer than the green line, then it's not a rectangle. Okay? So this rule, you guys wonder, when am I ever going to use this? I use this one all the time. Okay? I'm not going to pretend that everything I teach you I use all the time. Some of it, the only time I use it is when I'm teaching it to you. Okay? But this is one you can use all the time. Okay? You want to build a pole barn, you want the steel to fit on the roof, not to be crooked. There's something you'll want to do. You want to check your corners to make sure that they're 90 degrees. Here's a quick way of doing that. Okay? So this rule, diagonals of a rectangle are congruent, is very useful. Example, I just was talking about this. Pour a slab of cement in front of the garage. Actually, it's kind of what my current house looks like. Okay? So I take these form boards and I set them out here. And I'm going to exaggerate this a little bit so that you can see it's obviously not. It obviously looks not square, right? Okay? I just wanted to show you that if I take my tape measure 5, we say. Okay? So if I measure the other one, guess I'm gonna draw my line through that. Sorry. How long is that one?
Almost 5.
Yeah, almost 5. I'm gonna say 4.95. Okay, are they equal? No. So there's proof, according to that last theorem, there's proof that this is not square. Okay? So I'm looking at this, and I've got my stakes here and here, and I've got my strings. I've got my strings so that I can pull them left and right, move them, each way. And I see that this line is longer than this other line. So that means in order to square this up, I'm going to have to move my stakes this way. Okay? So I take my form board and I move it over a little bit. And I move this one over to match up on the end of it. And I get something looks like that. Looks like there we go. And so now if I measure this again, so now this line, I get 4.8. Okay? Let's see how we did on the other side now. Didn't quite get that to lay where I wanted to. It's pretty close now. I couldn't quite get it to stop where I wanted to. I draw that line. How long is that one? 4.8 again. Okay? So both of my diagonals now are 4.8. So now I can feel good about my slab of cement being square. Okay? Just a quick check. All right? Something that could be very useful no matter what you're doing. So this summer you're out helping your dad and he's trying to do something like this. Hey, I know how to make sure this is square. My dad used to take a little carpenter square. That's, I didn't draw that very well. Kind of like that. And this carpenter square would be 2 feet long on one side and 1 foot long on the other side. And he would lay that onto a board. That was quite a bit longer. And lay it right on the edge and attach it to it. And then he would use that to try to make this 90 degrees. Well, that's a good way to get started. But in a long distance, if you're just a tiny bit off laying this on the edge, or if your board's not perfectly straight, then that's going to mess things up. But that's a good way to get started. But then go back and double check your corners to make sure that you have a square slab, okay? All right, I'm gonna pause this, so all three of these are on the screen, let you copy it, and then we'll talk about each one of them. Did these look familiar to you? Yeah? Did they look like the three we just did? What are they compared to the three we just did? What is that C word? They're converses. That's right. The others start out by saying, hey, if these are parallelograms, then these three things are true. I shouldn't say it that way. They start out by saying if these are a rhombus or rectangle, then these three things are true. These go the other way. These are ways to prove that it's a rhombus or to prove that it's a rectangle. Okay? The difference is, in the first one here, it doesn't say we need both pairs of, or both diagonals bisecting angles to know it's a rhombus. We only need one. And at first thought, I'm thinking, well, how about a kite? But here's the problem. Diagonal of a parallelogram. A kite is not a parallelogram. Opposite sides are not parallel and they're not congruent. Okay? So a kite doesn't apply here. So my first thought, where this rule took me, I looked at it real closely and thinking, well, wait a minute. Did I make a mistake writing this down? Because that doesn't work. Well, my flaw in that is that right away at the beginning it says, if one diagonal of a parallelogram. And again, a kite's not a parallelogram. So we can throw that thought out because that was a bad thought. Okay? So we're saying if this is a parallelogram, so we have a parallelogram drawn here. Alright? So we have a parallelogram and it says if one diagonal if one diagonal bisects two angles of a parallelogram, then it's a rhombus. Okay? So we only need one diagonal to bisect the two angles. Alright, then it's going to be a parallelogram. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So these are strictly the converses of what we just did a minute ago, with the exception of number 4. It's worded slightly differently because we don't need both pairs. Okay? Any questions on that? On what they're saying? 16 problems today. You're going to practice. We'll practice using these 6 theorems.